Hello, everyone. My name is Anush Saburi. Today, I'm going to talk to you about how Certificate Authority Service can be used for Zero Trust. I'm a product manager with Cloud Security team working on Zero Trust. We're honored to have Jonathan Perry uh, from Goldman Sachs to talk about their journey to Zero Trust, and James Duncan, customer engineer from Google, my partner crime in this journey. So, the core of a zero trust approach is the idea that the implicit trust in any single component of a complex interconnected system can cause significant security risks. As such, it is recommended that the identity and authentication happens constantly and continuously verified. We believe that the zero trust security requires a highly available and scalable identity and credential system to build an identity based zero trust access policy. Let's consider an example of a microservices, right, where you break a monolithic application into a number of microservices. In this case, an in-process procedure call is translated into remote procedure calls or RPCs that happens over the network. As you can imagine, as these microservices communicate to each other, they need to be able to authenticate each other to make sure that this is a legit microservice, and also making sure that the microservice is authorized to make that call. As a caller of this RPC, I want to make sure that my call ends in the intended target microservice for this. And more importantly, the communication between microservices are not tampered with in transit. So as you can imagine, it's very important to build an identity for these microservices that is really not to an IP address because that changes, and making sure that the communication is encrypted with a credential used to authenticate the individuals, normally mutual TLS. And this doesn't only apply to microservices. You can imagine other endpoints like IoT, devices, SaaS application, but it goes back to the core point, which is identity and credential is key in building any zero trust solution. Now, we believe that a successful zero trust credential system should have three components. In our terminology, we use a SPIFFE as the identity format and X509 as a certificate, X509 certificate as the credential format. Those three components, in our opinion, is one, a highly scalable credential issuer, certificate authority in our case. The second is a component that deals with identity and federation management, such that different components of your system that may run in different environments can talk to each other through federation. And lastly is a managed credential that allows you to manage the lifecycle of the credential, for example, rotating the certificate, and also automatic distribution of the configuration. For example, what the root of trust, what are the federation policies, what is the rotation frequency for credentials. With that, we introduced a product called Certificate Authority Service. It's a highly available and scalable private CA in cloud that gives you full control over the lifecycle of your CA. It is built with three pillars in mind. One is simplicity. With CA service, you can configure a CA in a matter of seconds rather than months it used to take. Second is it's tailored for you, meaning that you can customize almost everything about the CA. That includes where the CA runs, which region, where the private keys are protected, for example, Cloud HSM, or you can bring your own keys, who get access to the CA and under what conditions, what are the advanced policy that you can enforce when issuing a certificate, and so on. And lastly, and more importantly, is that it is built with security in mind and enterprise readiness, right? When you look at the compliance and leveraging Cloud HSM, which is FIPS 140-2 level 3 validated, FedRAMP compliance, and so on. This product went to GA July of 2021. Today, we're happy to announce a new feature of this product that allows you to bring your own identity into the system. So natively, CA service works with the GCP native identity format. But now with this feature, what you can do is to use it to attest to a third-party identity using the GCP Workload Identity Federation. In this case, the certificates issued from the system can be equally used for users or workload certificates. And today, the GCP Workload Identity Federation supports a variety of different third-party identity providers, such as Active Directory on-prem, Azure Active Directory, AWS, or any OIDC provider. So what are the use cases this can be used for? Number one is for workload certificates. Imagine you have an on-prem workload that needs to talk to a cloud environment, right? And both of them needs a certificate to be able to authenticate to each other and later use that for TLS connection. So with this feature, what you could do is to enable CA service to issue such certificates, which are SPIFFE based, and the SPIFFE format will be included in the issued certificate in the URI extension. And here's an example of how it's going to look like, where you can see that there is the workload identity pool name and project number used as the trust domain and namespace, and then you can identify the workload using any part of the claim that you want in the issue certificate. The second use case is for device certificates. Similarly, you can use and configure the CA to issue certificate to devices that then you can use to connect to other endpoints in your environment, including the Wi-Fi endpoints, for example. And you can see that we're trying to democratize the endpoint and not be opinionated about the format of that. Now, what does the setup look like? It's actually very easy. You start by creating a workload identity pool with your favorite identity provider. In this step, then you can teach CA service which part of the token, the identity token, should be reflected in the certificate. For example, the assertion subject goes into the subject name. And then you configure your workload with workload certificate requester IAM role. You configure your workload to perform a token exchange with STS before talking to CA service, and then put the CA service in the reflected SPIFFE subject mode. All of these steps can be fully automated, which means that really, as soon as your workload comes to life, it can automatically get a certificate from cloud that reflects the SPIFFE identity and is ready to go to talk to your cloud environment and have the guarantee of a zero trust encrypted authentication channel between the two of them. So going back to where we started, we mentioned that the core of a zero trust security system is a zero trust credential system, an identity system. And we believe that CA service can act as that, right? Today, you saw how these two parts are available. So it is highly available, scalable, credentially sure, of course. And then with the new feature we just announced, it now supports identity and federation management. And this works in any environment. The endpoint doesn't have to be in GCP. It could be running on-prem. And in certain environments, the solution also provides a managed credential, meaning that the product takes care of rotating the certificates and distributing the federation. And these environments today include GKE when configured through Traffic Director, or Anti-Service Mesh, and GCE when configured through Anti-Service Mesh. But we plan to expand upon this on pretty much all environments that GCP owns. And what this means is that in simple terms is that you can set up a cluster in GKE and automatically every pod in the GKE will get a certificate from CA service ready to go to be used by your application microservices. It is truly magical. But the key point here is it takes away the error-prone and time-consuming jobs of what infrastructure should be away from the customer and allows customer to focus on higher business goals and achieving what they want to do with their solution. And this is actually a perfect gateway to pass it to James Duncan to talk to Jonathan about how Goldman Sachs is leveraging these solutions in building their zero trust solution. James, please take it over.
Hey, thanks, Anush. Thanks for the great overview of CA Service and some of the exciting new features the team is rolling out. And today with me, I have Jonathan Perry. It's great to have you here, Jonathan. Are you able to provide a little bit more information into what the consolidated trade ledger is?
Sure. So we have a division inside Goldman Sachs called Global Markets. And the basic business of Global Markets is to write contracts against customers, right? Or with customers. And then manage those contracts, a life cycle over time. We do that in ledgers, and we have like 50 ledgers, like probably across the entire division. The consolidated trade ledger is, of course, building the 51st and then moving all of the stuff onto the 51st. We will finish moving all the stuff onto the 51st. So it is taking a large data set. It is putting it into a single place, and then it's building a bunch of services around that large data set to provide the business logic that is involved in managing the lifecycle of the contracts.
No, thanks. It sounds like an incredibly complex system, and I think cloud is the right place for that to land. Are you able to tell us a little bit more about your partnership with Google Cloud?
Sure. So the beginning was basically we tried to figure out what it would take to put all these things in one place, and what does it mean to make a single ledger? What do you really need? And the first thing you need is global ordering, right? And to get global ordering across a truly global data set, you need external consistency, and therefore you need Spanner. You start with Spanner, you go to GCP. So that's kind of what brought us to GCP. And that's why we came to you guys and we started to think through how we would actually accomplish this rather, as you say, complex and mammoth project.
No, it's been an exciting project to tackle, and I think we've made some great progress. As you're moving this trade data into the cloud, what are some of the core security concerns that Goldman Sachs has had to consider? And also, why have you considered zero trust security to cover these?
So it's worth stepping back and thinking where we started from. So the place we started from was the usual setup of you've got a hard perimeter around a squidgy little big middle of your network, right? And that makes it really nice and easy for your developers, because your developer can just write your services and everything's reachable and it's all nice and easy, because you just sort of don't have to consider like security. I mean, that's a little strong. You obviously have to consider security, but you can offload it, a bunch of it, onto your network perimeter. Now, obviously, when you go into the cloud, you don't really want to think that way. You don't want to have your sort of, your hard perimeter. You want to be thinking as your service can protect itself. And that's where we got to, why we started thinking about zero trust.
Yeah, so it's like the migration to cloud has given you an opportunity to start to really challenge some of these traditional security mindsets. Yes. And as part of that, as part of this migration, what are some of the key principles of zero trust that Goldman Sachs has been implementing?
Well, so I'd say that I've really been learning about zero trust. So it's a little strong to say the principles, but I think that the idea here is you start from the center of the service, and you say the service has to be able to protect itself. And fundamental to that is it needs to be able to know the identity of all the things it's going to talk to, right? So everything else, when it comes in, has to be able to say, I am X. The question is, what is X, right? It all comes down to authentication. You have to be able to say the identity and then prove that identity to the person you want to talk to, with nobody in the middle, nobody that you're going to talk to say, like, who is this thing? You just say, I am X, you are Y, I will talk to you, I will, let you do whatever it is to operate against me, on me. Call my APIs.
No, I think you nailed it. What are some of these key challenges that you've had to overcome as part of this process?
Well, there's been a ton. But I think the biggest challenge has been how to do it homogeneously. There's a word. How to do it homogeneously. So you want to be able to say, like, in just one way, how you can express this service's identity and how you can make these two services talk to each other. So we've chosen just one way for everybody to bootstrap their own identities, which is all the stuff that Anush has just been describing. And we have one way of communicating with each other, which is point-to-point gRPC, and everything just integrates with that. And we have traffic directed to do all of our routing. So it all becomes very, very homogeneous, very low toil, very low operational cost.
No, that sounds great. It sounds like a very elegant platform. What are some of the appealing things about Google Cloud's approach for zero trust security?
It's all about homogeneity. I mean, so the place I came from, right, is this place inside, is this group inside Goldman Sachs, which is called SecDB. And the idea of SecDB is you have one platform and you build everything homogeneously, and you sort of force quite a lot into the same shape. But if you can force everything to the same shape, you end up with something where you don't care where this thing runs, you don't care how this thing runs, you don't care what machine it's on, it just all works, right? And that's what's appealing to me about how GCP have attacked this. Basically, as Anush was saying, you take your identities, you stick an annotation on your pod inside GKE. Hey presto, your identity turns up, and you can then just use that to talk anywhere you like across the entire world, across a single network. Go. It's very nice and homogeneous and very simple.
No, great. That's awesome. Thank you. And as part of this process, how have you found CA Service helping this sort of identity transformation, along with some of the new features such as the third-party identity reflection?
Well, so the CA Service and the just provision of workload identities inside GKE has been super nice, because it means, like, I don't care if a thing's running in Asia or New York or whatever. It just gets the identity and all just works. So it like lives on top of Spanner really nicely, because Spanner obviously lets us not think about transactions across the globe, and now we don't even have to think about services across the globe. All just works. But then the next thing, the thing that Anush just announced as GA, the point that we can then use the same technology to talk to things on-prem, super cool. Because now we can say, I've got this service, starts up on-prem, exchanges its on-prem identity for a certificate, and now we get point-to-point connectivity between our on-prem thing and one of the GCP-based services, and we're zero trust all the way. Really nice.
No, that sounds super smooth, and it allows you to take that hybrid cloud approach and really allows you to implement zero trust security more than just inside the cloud. It expands that to on-prem as well. Exactly. And what would be required to achieve these similar outcomes without GCP?
It's such a hard question. I mean, I didn't write the private CA service, so it's very hard for me to tell you how hard it was for you guys to write it. I think it was quite hard. But I think that kind of points it out, right? So there's the just the technical challenge of how do you issue however many millions of certificates per second you guys can issue. I don't know, whatever, hard. But then the second thing is, how do you then integrate it with all of the services so that it all just arrives? So like GKE will just hand you the certificate. Traffic Director will just tell you, here is how you talk to that service, including the authentication mechanism, right? Those kinds of things become much harder if you're doing them yourself versus if you can just go into a single integrated environment, dive right in, and get it all kind of for free. Except we do pay you, obviously, we pay you, but for free.
Hey, you pay us to make the hard things simple, and that's what we're really focusing on there for you.
That's right.
No, thank you very much, Jonathan. I'd like to thank you, Anush, for giving us a great overview of CA Service and some of the exciting new features we're getting to see roll out into the market. Jonathan, it's been great to have you here to share your story with implementation of CA Service and the CTL initiative. And to everyone else for watching, thank you for joining us today. If you'd like to find out more about CA Service, you can read up on the Google Cloud landing page for CA Service or reach out to your Google Cloud account team. Thank you and have a great day.